or well, I'm Leo. I'm a core developer at Node, and I'll be talking about to you today about our collaboration with Near, which has been going on for well, at least this entire year, and eager to share all of our results. So first, I want to tell you a story, and here you can see two Near DApp developers. You have one front-end guy and one, let's say, a data science guy. So they are building their DApp, and it's already, they've got the smart contracts all built on deployed on Near, and they need to get the data out. So they look at this wall of blocks, and they know the data is there somewhere, but they don't know how they're going to get it out or how they're going to organize it to do their data analysis or build out their front end. So looking at this wall of blocks, very confused. So they asked their friends in the blockchain ecosystem, how do you build your dApps? How do you build your front ends? How do you get the data out of all of these blocks? And they asked around, and all of the Ethereum people, Jello people, Avalanche, Phantom, BSC, and so many other networks that Polygon, so many other networks that the graph already supports, they all pointed him at the same direction. They told him, use the graph. But the Near DApp developers told him, well, we don't have the graph. We're lost here. So today we're very happy to announce that the graph has come to Near. So the app developers rejoice. You have been saved by the graph. Yeah, so let's get into how all of that works. So this is a Near subgraph. Depending on how familiar you are with subgraphs, a subgraph carries a definition of a GraphQL schema, because we expose a GraphQL interface, which is just what those DApp developers want when they're dealing with data. Is something a technology that they already know, possibly from different backgrounds. Even from Web 2, GraphQL is very, it's widely used. So we just want to give you a single, it's not really, each DApp develops a subgraph, and the subgraph contains a GraphQL API that is tailored to their use case and to their needs. And the subgraph, to provide the data that backs that GraphQL API, will track data sources. So when you talk about a subgraph for Near, you need to define what a data source for that subgraph looks like. So this is a data source. So kind has to say Near, and network Near mainnet, and so the source is an account, right? So because that's how, for example, in Ethereum, it would be a contract address. Here it's an account. So you have the account string, start block, in case you don't want to have to sync through the entire chain from Genesis. And then there's something interesting at the bottom there, which is the handler kinds. So at launch, we're supporting two types of triggers, two types of handlers for Near, which are block handlers and receipt handlers. So block handler is something that's going to trigger on every block. In case you need to update something on every block, it's going to have access to the block header. The receipt handler is going to filter on the receipts, which have the associated with that account that you configured up there. And you're going to be able to parse the receipt logs and the actions in that receipt and any other data associated with the receipt. So this is an example of a handler. So the data sources define what data you're going to take as an input, but then you can transform that data. You don't just because you need to organize that to suit your GraphQL API. We're not just exposing the raw data. So with the mapping, this is going to be very familiar to assembly script developers because it's an assembly script. So you write your mapping in assembly script, and you handle that data and store it as entities into the graph store, right? The store for your subgraph, and those entities are what's going to be queried through GraphQL API. So here's an example handler, a handler for a receipt. You can grab the receipt ID, And to illustrate one very common use case, which is to parse the logs. So you can parse the receipt logs and use, it's very commonly, people put JSON in the logs, some structured data, and you can parse those, and then you can do just whatever you want with those logs. Use your payload to create the entities. So of course, everybody wants to know, okay, so when can I use this? And that's basically today. We have our docs already live. You can check them out, start building out your subgraph. It's going to be live in our hosted service, which means that on thegraph.com, you need to head to the Legacy Explorer to deploy those subgraphs. And yeah, and later today is not, you cannot, just right now you cannot deploy them, but later today it's already going to be available. And yeah, please start hacking and let us know what you think. You can contact us at near@thegraph.com. If you want to build a Near, we're very eager to know what you're building and help you out in any way that we can, and show up on our Discord as well. But yes, when? Right now. But I must give the beta alert. There's like the V0 of the Near and the graph integration. It's very much beta. Things might, subgraphs might stop syncing, things might break, things might change. But that's also, in a way, it's a good thing because it means that developers can give us feedback and we can incorporate it quickly because we really want to iterate at this beta stage. So please do try us out and give us all of the feedback that you have. And now I want to, tomorrow, my colleague who also at Node, Adam, is going to be also giving a talk, and he was going to give more of an overview. But I want to dig today into a bit of the weeds of how this integration went and how we built this over the last 6 months or more, really. So this is a collaboration between 3 development teams. Near core team was very important because of the Near indexer framework. Streaming fast, also hugely important because they built the firehose, which I'm going to explain in a moment what the firehose is, but it's a new architecture to feed data into the graph node. The graph node is what does the core subgraph indexing. And Edge node, which maintains the graph node, which is what our indexers run to keep the graph network running and indexing those subgraphs. So, what are you interested in a Near block? So this is a Near block from the point of view of what's relevant to the graph right now. And so it has block header, has a bunch of receipts that have been executed at that block. And the receipts have the logs, or they have function calls, and things that are relevant for developers to handle in their subgraphs. And so, how do we get those blocks, into graph nodes so we can feed them into the mappings? So this is the firehose architecture. So over there we have the Near DeepMind. The DeepMind component is an instrumented node, which takes the data directly from the Near node and communicates it over gRPC. And here the indexer framework by Near was fundamental because it basically already provides you with an instrumented Near node with the hooks. So you just have to plug in the gRPC streaming directly into the indexer framework. So that was the very important part from Near core that was used. And then all of those, the arrows are just blocks flowing through gRPC through the system, the blocks that I just showed. So when we have the instrumented block, it goes to the block store. So that from the next time we scan, because when a new subgraph gets deployed, we need to scan the chain again. Next time that we scan, it's going to be in a store so that it's quickly accessible. But also we need to listen to the network live to the new events and the new blocks. So that's what the relayer does. New blocks for optimal latency get fed directly into the relayer. And then from the relayer goes to the fire hose. The fire hose will parse the data and do the gRPC stream, emit the gRPC stream that goes into graph node. So that's the fire hose architecture, and that's what Streaming Fast, which is a core team at the graph. Agile Node is one core team, Streaming Fast is another core team, and Figment is a third core team, which is also working on we are all working on this stack, on the fire hose stack. Yeah, and that's the technology that Streaming Fast brought to the table. And now I'm going to dive a bit into Graph Node, which is yeah, a bit more of my personal expertise. So how does Graph Node become multi-chain, right? How do we, because so far the graph was only Ethereum and EVM compatible networks. So we had Ethereum written all over that code base. So how did we change things so that now it can be compatible with just about any blockchain in principle? And now Near is the first example of that. So the structure, if you're familiar with Rust, you have the crates, which are packages. So we have the graph core package, which does not know anything about specific blockchains, and then we have all of the specific things for Ethereum or Near into a completely separate package as a dependency. So we have a nice separation. And to abstract a blockchain, first you must abstract a block. And it turns out the graph node doesn't need to know a lot of specifics about a block. We need a block pointer, which is just a number and hash, which you can expect from just about any blockchain. And a block must have a pointer, a number and hash, and it must have a parent pointer. If you're familiar with Rust syntax, an option means that it's nullable. The parent pointer is nullable simply because Genesis doesn't have a block parent, right? So to handle Genesis, it must be an option. But that's really all of the assumptions that we do about a block. Everything else can be entirely up to the specific chain, and this allows us to have all of the flexibility to have any sort of custom handlers or triggers like we have the receipts for Near. So this is the blockchain trait. So a trait, if you're not familiar with Rust, a trait is like an interface from other languages. So we just defined the block trait. So the blockchain trait has a block type, which must implement the block trait, which we just saw. Yeah, so this is going to be the essence of what a blockchain is to Graph Node, right? And I really, at the end, don't need to assume a lot. We need to have a data source that we just saw in the previous slides, the definition of a data source for Near. We need triggers, such as the receipts and the block handlers, and they need to have an order because Graph Node needs to execute things deterministically, so they need to have always a deterministic order. You need to be able to have a block stream, which is fed by the fire hose, which you just saw. And you need to be able to pull the blocks from the triggers from a specific block. And when you have a trigger and a data source, you need to know if that data source is interested in the trigger and it has a handler for that trigger. And that's really all we need from the specific blockchain package. The Near package has an implementation of blockchain for Near. So this is how you implement Graph Node in 9 lines. Reality is more complicated, of course, but this is pretty reasonably accurate. For each block and block stream, for each trigger in the block, using those functions that we just saw, for each data source in the list of data sources in the subgraph that we just saw in the YAML syntax. If that data source matches that trigger, if it has a handler for that trigger, then process it. Send it over to the runtime, the assembly script, WASM, to be processed. So that's it. Then if you have that blockchain trait defined, the Graph Node will give you the GraphQL interface. It will give you the store. It will handle reorgs for you. It will give you the WASM execution and a bunch of other stuff. So this makes it really a pretty simple process to plug in new trigger types, which we're also going to have for Near, or really entirely new chains. So we don't care if your chain, it's like has crab claws and antler horns, or if your chain has the feet of a platypus and the horns of a rhinoceros, or if it flies, or if it walks, or if it crawls. If it can conform to that interface, very simple interface, the graph is going to be able to index it. So what do we have in store for the future? Function call handlers for near, because we do have the receipt handlers, but that's the function calls are a bit more granular level. So because emitting the logs, the receipts are great for parsing the logs, but emitting the logs has a gas cost for the contract. So if we could just parse the function call arguments directly, that would save gas for DEPs. So that's something that we want to include. Data source templates. If you have like a factory contract pattern where you don't know offhand which accounts exactly you want to track, or maybe you want to track an account and its sub-accounts, that's something that we are also see as an extension. The decentralized network, of course, because we have launched our decentralized network. Right now, we only support Ethereum mainnet on it, but we are working on bringing the full support for all of the chains that we support on the hosted service gradually, and eventually also, of course, near on the decentralized network, so that we can benefit from the reliability of having indexers distributed around the world indexing your subgraph. And Aurora, of course. Aurora actually is EVM compatible, so in that sense, it should be, we should probably have it soon in the hosted service as well. And also a new type of handlers that you could think of is like state change handlers, which means you track like a specific state variable in a contract, and whenever that changes, you have a trigger. So that could be like the most granular possible level of trigger. But as you guys saw, in our architecture, any trigger that you can pull off a block, any data that's there, you can, if the near indexer exposes it and the firehose can pull it out of the block, it's a very extensible interface. So you can give us feedback on what type of triggers you'd like to see in near subgraphs. And that's it. Happy graphing.